All right, 6.5, proportions in triangles. All right, so today we're going to be reviewing, not reviewing, I mean we are learning new theorems, but kind of reviewing the whole proportion thing that we've been working with. All right, first one is the side splitter theorem. Side splitter theorem. Okay. Now if you draw a triangle, we're going to label this triangle X, Y, and Q. Now I'm going to draw a line that's parallel to XY, but it's not necessarily the mid-segment. So this is not the mid-segment theorem. So I'm going to purposely draw it so it doesn't look like it's the mid-segment. It doesn't matter exactly where you have it, as long as you don't confuse it with the mid-segment theorem, because this is different. Okay, so I try to make it obvious. Can you tell that QR does not equal XR? Mm-hmm. Right? All right, so even if it looks it, you can't assume it unless it says it is a mid-segment or if they have the markings. So again, not a mid-segment problem. Are we ready? Yep. Okay, so when you have this side splitter theorem, it states that if RS is parallel to the base, if you have two lines like this that are parallel in a triangle, then QR over RX equals QS over SY. QR over RX equals QS over SY. Left over left equals right over right. Got it? Okay, we will write it different ways, but let's just get this practice for now. What?
When will I just be graded?
They're graded.
Oh, when will they be in?
Probably not until tomorrow, but we're going to try to see them today if we can get to the notes.
Okay.
All right. Okay. Example. Example 1. Here I'm going to have you solve for X. Okay. This top piece here I'm going to label as X. This bottom segment here I'm going to label as X plus 4. The right top segment I'm going to label as 12. And the bottom right segment here I'm going to label as 18. So that was X, X plus 4, 12, 18. Now, there are more than one right way to write it. There is more than one right way to write it, so I'm going to go over some of them with you. All right, I'm going to use just this one here, which would be X over what? X plus 4 equals 12 over what? 12 over 18. I will give you a little bit of time to solve it on your own. You do have to remember that what do you do here with the 12 and the X plus 4?
Cross multiply. Distribute.
Distribute. We are going to cross multiply for sure. Do not forget to distribute the 12 to the X and the 4. Cole, was it hard to see from where you were sitting?
Oh yeah, I was just leaving the wood turn my head.
Okay, okay, that's fine. All right, do you guys have answers?
Yeah.
I just want to quickly go over solving because I still have, when I was going through the test, I still have students making mistakes on solving equations. Some of the things that I've seen, first off, should I move the 18x to the right or the 12x to the left?
12x to the left.
Yeah, I could go either way, but it's easier if you just get the x's off to the other side. 12x, and it's not always that way. It just works out this way in this problem. Here's another mistake I see kids make. They'll put minus on this side and plus on this side. Not quite sure why, if it's just going too fast, but if you're subtracting on one, should you be subtracting on the other? Yes. So be careful with that. Slow down if you're going too fast on the test. All right, gone here. What's 18 take away 12? 6x equals 48. Divide both sides by 6. And what does x equal?
8.
X equals 8. All right, are we good?
Great.
Okay, I do want to talk about the other way to write it because I had a lot of kids asking in my class yesterday, could I do it like this? So you tell me. The question they were asking is, I'm doing left over left and right over right. They asked, this was their question, and yes, I want you to write it down with me. Could I do top over top and bottom over bottom? So could I do x over 12 equals x plus 4 over 18? Do you see how we did that? Top, top, bottom, bottom. All right, let's check. When I multiply this way, what do I get? 18x. And when I multiply this way, I'm not going to distribute, but do I get 12 parentheses x plus 4? Yeah. I'm going to stop there. I don't have to solve. Is this exactly the same as what I have over here? Yeah. So if I actually went through and did all the work, would I end up with the same answer? So does this way work as well?
Yes, it does.
Yes, it does. Now they said, what could I do, like x over 18 and 12 over x plus 4? No, you can't jump across. You can do left, left, right, right, or top, top, bottom, bottom, but you can't jump across. Now, here is one thing I did see and I want to just warn you about. Some kids, okay, do you agree if I use this way, I'm cross multiplying kind of like if this was my fraction? X times 18, x times 18 and 12 times x plus 4. Do you see that?
Yeah.
All right. That doesn't mean you don't show your work, and you guys should know that by now. I still need to see this equation on your paper. All right, so you're making this proportion, and then you're solving. Don't just like, oh, boom, 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 I'm good. Got it? All right. I'm going to move on to a different theorem. Before I do, any questions on the side splitter theorem? Okay. Next one is a corollary to the side splitter theorem. Now this means it's very similar, but just a smidge different, so it does require its own picture, its own proportions. Corollary to the side. Is that coming from my purse? Can you just turn it off for me, please? Thank you. All right, corollary to the side splitter theorem. Thank you, Liberty. All right. Before I draw my other line, I shouldn't have even drawn that one yet, but if you did, that's fine. I'm leaving it. I'm not erasing it. It's okay. But what I want to draw, what I should have drawn first was 3 parallel lines. It does not matter how, like the length or the distance between your 3 parallel lines, as long as they are parallel. All right. Okay, so what we're going to have are 3 parallel lines cut by 2 transversals. This is what we've had before. We've always had 2 parallel lines cut by 1 transversal. But now we have 3 parallel lines cut by 2 transversals. And what ends up happening? All right, I'm going to put my parallel markings in. And I'm also going to put letters. This point of intersection here is X. I'm going to call this one, and actually I'm going to take that back. I'm going to go back up and call that A. I'm going to call the second one B. AB, and this one here I'm going to call C. All right, so then this one I'm going to call, on the right side, these points here, I'm going to call WXY. WXY. Okay, so proportions work just like this one here, except it's not a triangle. That is the only difference. But do you see how I did over here, left over left, and then right over right?
Yeah.
Same thing. So I'm going to have AB over what? BC equals, I'm going to have you guys write the rest. I gave you AB over BC equals, and now go to the right side. What would it be?
WX over
Over XY. Good job. All right. Make sense?
Yeah.
Okay. Very similar, except the picture just looks different. Got it?
Yeah.
Okay. Questions before we move on to the example that matches this? Okay. Example 2. All right, A, I'm going to have you find BC. Remember, when it's written like that, BC with no segment, this is the same as saying find the length of BC. B is find AC, again, which means find the length of AC. All right, I'm going to draw my 3 parallel lines. All right, I'm going to call this A, this one B, this one C. Now I had a kid ask, like, why did you put A on that side? It doesn't matter where you put A. I just didn't want to squeeze it in there because it was too small, but it doesn't matter. A, B, C, and W, X, Y. W, X, Y. All right, I'm going to put a 6 here for the length of AB. The length of BC is X. The length of WX is 18. And the length of Y is 12. Got it? Okay. Now, going to make our proportions. Now I'm just going to do left, left, right, right, and we'll talk about if there's any other ways. So if I do that, it's going to be what? 6 over, this is part A, 6 over X equals 18 over 12. I'm going to go ahead and let you solve that now. You have your calculators. Don't forget to show your work. Don't just plug it in and get an answer. What did you guys get?
4.
X equals 4. And again, you show your work. You don't just plug in, like multiply and then divide, which a lot of kids do. Okay. Before I move on to part A, and I am going to take a step back and tell you this. You don't have to erase it. This wouldn't be there, and I shouldn't have put it there, but I did, and I am going to put it back, so don't bother erasing. It'll look like this on homework or quizzes or test. 6 blank 18 12. Now the blank is the BC that we're looking for. Do you see that? Yes? Now when I want to make my proportions, you could label that denominator BC, but I'd rather not. So that's where I just say, okay, let's call it, and what letter did I have there? X. Could you have called it Z? Element OP. I already have it there, so I'm going to leave it, but I typically wouldn't have used that because of that X there. But I'm hoping that doesn't confuse anyone. All right, so back to the question on can I rewrite it different ways? So instead of 6 over X, what's another option we could have done? 6 over, I can't go diagonal. 6 over what? 18 equals 12 over X or X over 12? And I'm just going to do a visual. Does it work? Here I end up with 18x. Is that the same thing I have here? Yes or no? And here I have 6 times 12. Is that the same thing I have here? Yes. So does it come out the same? Yes. All right. I'm done with part A, and I'm going to erase the x equals because what did they ask us to call it? BC. BC equals 4. All right. Part B is asking us to find AC. AC is from this piece to this piece. So what do I do with the 6 and the 4? Add them together. 6 plus 4. So AC equals what? 10. Questions? Okay. I am moving on to the last theorem, which is called the triangle angle bisector theorem. Do we know what an angle bisector is for a triangle? Yes. All right. So remember, an angle bisector bisects the angle. It doesn't have to be perpendicular to its opposite side, but it does bisect the angle. Okay. Are we ready? So if you have a triangle with an angle bisector, here is what ends up happening. CA, I'm just going to do left, left, right, right like we've been doing. So that would be CA over, oh, and I need one more labeling here. I'm going to call this D so that we can make our proportions. So D is not part of your triangle, it's part of your angle bisector. AD bisects angle A. Do you see that? All right, so CA over CD, and I'm going to let you finish the rest. I did left over left equals right over right. CA over CD equals what over what? CA over CD equals what over what? Do you guys have it? What is it? AB or BA is up to you. Over what? BD or DB? BD. All right. Are we good? Okay. So, again, we'll talk about if there's other ways to write this one as well. Let's do a quick example. Solve for x.
Can you read it back?
Mm-hmm. Okay. This is 12, this segment 16, this one is 20, and this is x. All right, I'm going to have you make your proportions and solve it on your own. If you're not sure how to make your proportion, you can ask someone in your group. Like what goes on top, what goes on the bottom. Does it confuse anyone that it's upside down? Okay, so I will start you off. The upside down does not matter. And it doesn't matter if I start with 12 over x. I'm just going to do top, bottom, left, left. So 12 over x equals blank over blank. 12 over x equals blank over blank. If you wanted, could you start here and do x over 12?
Yeah, that's what I did.
Sure. You could do x over 12 equals 20 over 16. Does it matter? No? Okay, I'm going to do x over 12 equals what over what? 16. If I do 12x and I have to do 1620. Yes? All right. What does that give me? 12 times 20 is what? 240 equals x times 16 is 16x. And then divide by 16, and what does x equal?
15.
X equals 15. All right, so I'm going to quickly talk about the other ways. Instead of doing top to bottom, I asked, could we do bottom to top? And some of you did, yes or no? X over 12 equals 20 over 16. Would we end up with the same thing? 16x equals 240. Okay, I'm not going to solve it because we know it's true. Now, if I wanted, could I do top, bottom, bottom? Let's check. 12 over what? Equals x over what? Let's see. 16, what do we do? 12 over 16. I'm sorry. 12 over 16 equals x over 20. Here I get what? Do I still get the 16x? And here I get 12 times 20. Is that still 240? Does it work? Yes or no? Yes. Check, check, and check. They all work. All right. Could I do 12 over 20 and 16 over x? Can I go diagonal like that? Payne, you answer for me.
What?
Hmm? She was.
I'm already done.
I know.
X equals
We weren't
15.
done yet, though.
Yeah, we weren't. I asked a question. I said, okay, first I asked, do all of these work doing these different ways? Okay,
Yep.
then I said, what about 12 over 20 and 16 over x?
No.
That is correct. No. We cannot go across. Left, left, right, right, or top, top, bottom, bottom, not diagonal. Got it? Questions?